decline the quality and the yield in our tea industry as well. So we asked about, are there any sustainable methods that we can introduce? Yes. We introduce virtual tea farming system by combining with the system thinking approach. In the vertical tea farming, we can grow more tea plant with less space by adjusting environmental parameters as well as other parameters as well. In the system thinking approach, we can see how different factors affect for each other by using whole picture of the tea plantation. So our main research objective is to develop a system dynamic model for simulate vertical tea cultivation in Sri Lanka, integrating by using causal loop diagram and simulation by using analytic software. This is the full workflow of our methodology. First of all, we identify what is the problem, and then we develop causal loop diagram for conceptual modeling to identify complexity of the mapping. After that, we identify what are the parameters that affect the yield and quality of the tea, and we normalize those parameters from 0 to 1 value by using literature-based minimum and maximum value. After that, we develop system dynamic layer by using analytic software. This is the methodology part, another methodology part. In here, we use secondary data from the published research and reports as well as TRL dataset. After that, we develop through causal loop diagram for traditional farming and vertical tea cultivation. After that, by using that, we develop system dynamic model as well. In the result and discussion, we develop two equations for yield and quality by identifying parameters from the literature. And these are the sum of literature that used to shape our model. In this shows, there are two types of modeling methods we identified. First one is event-based modeling and second one is agent-based modeling. So in our research, we use agent-based modeling as well. In the simulation model, stock flows and the reinforcing and balancing loop used for the developed system dynamic model. These are the references that we use for review agent-based modeling in agriculture field. So identify the complexity of the macro level in the vertical tea system. We use two types of modeling, and first one is system dynamic and other one is causal loop diagram. System dynamic is a methodology for understanding, modeling and simulating complex system over time. A system with a non-boundary consists of a group of parts or elements that interact with multidimensionally, adapting to achieve a specific function that used by using the causal loop diagram, and it has reinforcing and the balancing loop. So you can see here, this is the causal loop diagram for conventional tea cultivation, and this is the diagram for causal loop diagram for vertical tea cultivation as well. So you can see there is high complexity in the conventional tea cultivation rather than the vertical tea cultivation in vertical tea cultivation. After that, we develop system dynamic stock flow model by using analytic software, and we use the value that we identified from the literature and apply those things by using equations and factor values for each factors as well. In here, we can see yield and quality summary of the one after one simulation in the analytic software. According to this scenario, while we are changing the factors according to this scenario, we can see yield and quality and also labor reduction. We can see change the other scenario, and also we identify implications for stakeholders as well as model implications as well. Implications for stakeholders we identified for farmers, policymakers and investors. In farmers, we need to increase yield and reduce the labor, make vertical farming viable even for small holders as well. When we move to the policymakers, we need to provide evidence for target subsidies to make developer policies. And for investors, we need to demonstrate research of innovations ideas to control environmental agriculture by using term, and the model limitation is based on normalized parameters and the secondary data we use. So we need to calibrate by using real farm data as well. So our conclusion is, when we compare conventional tea farming with the vertical tea farming, vertical tea farming is most resilient and sustainable method for modern agriculture, and simulation findings provide decision support tool for sustainable tea farming policies and smart agriculture investment as well. So there are some recommendations as well. We categorize those into short term and medium term as well as long term. So in the long term, we need to develop cultivar specific module for the prediction with inputs from investors and exporters as well as agri-tech firms. In the medium, we need to test this model by using some policies who are with the policy makers